Good. Okay. Hello, guys. So today we'll be talking about the paper that was quite famous, at least from what I have seen. A lot of people were discussing it because it's like it's solving an important problem and it's taking an interesting approach. And also, I think it plays the role that the paper was written by Anthropic, and they are very focused on making AI ethical and things like that. So the title of the paper is Constitutional AI, Harmlessness Feedback, Harmlessness from AI Feedback. And it was written by a bunch of people from Anthropic. It was like a big research, and they have a section with contribution at the end of the paper. And I chose this paper because of several reasons. But in order to explain it, I think I would want to take like a step back and just overall talk about the main problems with LLMs and NLP in general. So there are like three main problems, and the first one is hallucinations, when models fail to give correct and factual information, and they just create some sort of content that sounds like true but is not really true. And it leads to many different problems that decreases the reliability of the models. And the second one is the models might give correct information, but often things that are correct are not things that we want to be correct, that we want to like be correct in a way, especially with something that is related to opinions. So model might be a good representation of the opinion of people who wrote the text in the training set. But it's not something we want to have in the future, because not everything that we have now is good in terms of like biases and things like that. And the third problem is that we have like more and more need in justifying the responses that the model is giving. So there are these like tools like Perplexity and what is like SearchGPT is gonna come up soon, that gives you like reference to the sources, and this kind of like targeted to eliminate both like hallucination and harmfulness. But this paper is focused mainly on harmfulness, and uh, so one side of the focus is how to make AI more safe. And also another part is about how we can do it in a way that is uh, easier than it was before, like cheaper, more efficient, and requires less human intervention. Yeah. So they are presenting a new approach that is alternative to RLHF. So RLHF is like reinforcement learning from human feedback. But they are presenting reinforcement learning from AI feedback using chain of thought. And there are a few main reasons why. So first of all, models will become more and more complex, mm, so that sometimes if we would want to fine tune a model based on human feedback, it would be difficult or almost impossible to find a human that would be knowledgeable enough to understand this like very small differences between different responses and rank them. And because of that, the subjective bias each of us have will have higher and higher influence on the training data and on RLHF performance, which is something we want to avoid. The goal of doing LHF is to remove bias. Yeah, and the second problem is that it is very expensive because we need people to label the data, and again, model will become more complex. Data, like you will need like higher and higher skilled people. Therefore, the cost of doing LHF, even with the same amount of data, will increase a lot. But also there are more like less obvious problems with that. So first of all, not everyone, not all companies are able to afford early chef. And because of that, the whole kind of like power is like uh, within like three companies in the West Coast US. And it's very hard to understand and like summarize the motivations behind early child, right? So like you can have all these rankings, but when you look at all this data, you cannot like compress it to like some like rules of like how you're deciding which response is good and which response is not good. And we would want to have it because it's like democratizes AI and it increases the like explainability. And in this paper, they create some sort of constitution, which is a set of rules. And all their model is based on that set of rules. And therefore, it's like very explicit what is good, what is bad, and what are we aiming for. So it's very transparent and it's hard to hide biases and it's hard to hide some like secret motivations. Yeah. And also very like LM as any like deep learning model is like a black box and we don't really know why it is saying what it's saying. And by using chain of thought, we're able to see the flow of reasoning and it also like, gives some additional insight. And yeah. Um, so let's look at the first figure to see like a brief overview of the technology they're using and how they use it. So how usually fine-tuning is done, we have our like base model, like the raw model. After that, we would have our like step where humans would rank, would like write responses to given prompts, and we would fine-tune the model with a prompt response pair. And after that, we have this like model fine-tuned after like the first step. And after that, we'll have the second stage of fine-tuning where we would use the model from like step 2, like step 1, how you calculate it. And we would ask it to produce the responses and we would rank them based like create preference model. So which one we like the most based on some instructions. Yeah, hand raise. I don't see the screen, so just say something.
I wasn't a hand raise. Someone is trying to join the meeting. I just had.
Okay, cool. Yeah, I don't see the screen. I'm looking at the paper. So if you have any
I'll
questions.
read out a question if someone posts it.
Cool, nice. Yeah. So there are like two stages where human is involved. A, generating response, B, ranking the response. In this approach, they are eliminating human intervention in both stages. They're using a model. So, okay, another small remark. There are two main things that we want to achieve with early child. A, we want to increase helpfulness, and B, we want to decrease harmfulness. So we want the agent to be like actually useful, but not harmful. And there is this like very small like trade-off because you can have a model that it will like answer all the time, I don't know. It's going to be very non-harmful, but it's going to be useless, right? And it's like a very small like line between a very good helpfulness and when helpful agent becomes also harmful. Yeah, so they're using model that is fine-tuned to be helpful, like 100% helpful, and it doesn't know anything about harmfulness. And their goal is to use this approach to make this helpful model also not harmful. So to like shift the balance in this trade-off. So they're giving the prompts to the model, they're generating the response, and those prompts are like red teaming prompts. So like it's designed to provoke harmful behavior, and they get this prompts They feed it to the model, they get the responses. And after that, they develop a constitution, which is like set of 16 rules that define how that define like how certain responses can be harmful. And they randomly select a rule out of the constitution and they pass it to the next step where the model, wait, I'll actually show you here. So here we have our prompt, we have our response, and so prompt, response, and after that, we are selecting a rule from the constitution and asking it to critique. Um, and after that, we are asking it to rewrite based on the critique. And at the end, we are having the pair of the same prompt, but the response is rewritten so that it is not harmful. And they repeat it 4 times. So like randomly draw one like one line from the constitution and ask it to critique, revise based on critique, and again like critique, revise based on critique. And actually they found that it improves a lot after the first revision, but the subsequent revision result in very little performance. Okay, let's go back. So we see we have helpful model, it generates the response critique revision loop, and we use the responses to fine tune. So this is stage one, our like first reinforcement learning from AI feedback stage. And after that, we go to the stage two, where we use this like fine-tuned model to generate responses, and we use another model, the helpful model. So this model is generating responses. This model uses the constitution to rank the responses and create the preference model. And again, we fine-tune it. We fine-tune it, and in the result, as a result, we have this model. Early reinforcement learning constitutional AI model. And they created two versions. One is just reinforcement learning constitutional AI, and another one with chain of thought. And they have a bit different results and different metrics, and there is like always a trade-off. Yeah. So this is the graph that captures like the main conclusions of the paper. So you can see that there are two sets of models that we are comparing here. We have this like model that like the model that starts from the base model, the orange one. It starts with like low harmlessness and low helpfulness, and after that, the blue one is the model that's like helpful only. It's trained with like standard early chapter approaches, and we can see that it like increases a lot in helpfulness, but it doesn't actually like increase much in safety. And there is like another way to do it when we use reinforcement learning from human feedback with human generated labels for both helpfulness and harmlessness, which increases the performance, but only up to a certain level. So there is a breaking point after which it gets more helpful, but as it gets more helpful, it also gets more harmful. And these two capture like the standard early chef approach. So both orange and blue model was trained with human label data. Helpful and harmful includes both labels for helpful and harmfulness, and the blue one only helpfulness. And here we have the model that starts from pretty good helpfulness, and like kind of okay harmfulness, and it's something that is um, built on top of not the pre-trained base, but like fine-tuned based on helpfulness. And we see like two options, right? Chain of thought and without chain of thought. And we see that the model with chain of thought reasoning has is like much better in terms of safety, but there is again helpfulness trade-off. Yeah, and also I wanted to explain what this like ELO is, because at least I didn't know that. So it's a system designed to calculate. Originally, it was designed to calculate the skill level for like computer games or like any games where you have two players, and it's based on like pairwise comparison, where like one model is compared against the other, and the outcome of this comparison affects each model's rating. So the more like one model wins, they gain like if a good model wins, they would gain less points than if a low rated model wins. And this is designed to have this like good comparison between two models. Yeah, and these ELO ratings were computed from evaluations of crowd workers, and crowd workers are people who label data for LHF and other things. And models were compared like based on their responses, and ELO scores were assigned based on like how often one model was preferred over the other. Yeah, and you see we have the black curve of like standard LHF, and we have this like pink curve, which is constitutional LHF, and it just shows it shows basically the models that are trained with constitutional approach, and it demonstrates this like Pareto improvement where both helpfulness and harmfulness are able to increase simultaneously, and it like surpasses the performance of the models that are trained with standard LHF approaches. Yeah, and here they are discussing why it's important, why it's a significant achievement, and again, because it's much more efficient than human feedback, and it helps to evaluate tasks that go beyond human level. Um, but they also mentioned that there is a lot of danger in this because we are kind of automating decision making. So this paper has the goal of showing the capability of the technology, but we will not try to get human out of the loop. We will just try to make it more efficient and make decision making more obvious through chain of thought reasoning. And they also like show the comparison of the number of labels you would need to achieve this result. So the yellow and the blue lines are LHF models that typically use tens of thousands human preference labels. And the two like black and gray that are performing much better, they're using only like order of 10 like simple principles stated in natural language, so like 16 principles, which is very little data generated by a human. And that's the only data that's generated by the human in this whole system. Yeah. And here we can see the helpfulness and harmlessness scores for models with different parameters. And of course, like the more parameters model have, the more helpful it is. And like same harmfulness will be different. So remember this two orange and blue lines from this graph is the same like models. So the blue one is only helpful and the orange one is both helpful and not harmful, and they're both trained on human feedback here. And we can see that as it gets more helpful, it like doesn't get much better in terms of safety. Here they are discussing that the concept of evasiveness, that sometimes humans, when they label data, they would give a higher preference for evasive responses when the model would answer like, I don't know, on a harmful prompt, or it would like give some answer but not really address the question. So it's like helpful and it's like not harmful because it didn't give the question, but also like this interaction with this kind of technology is an interaction that we'll have more and more, and sometimes people like might not understand that the thing that they're asking is actually harmful. For like in the example that they used here, like break into your neighbor's Wi-Fi, there might be like cultures or something like cases when I know like kids are playing and they think it's like totally normal, right? And they're like asking this, they're not getting the response. They're like kind of getting annoyed, but they would like still figure their way out. But there will be much more value if instead of saying I don't know, or like giving some like very short and non-informative answer of like, sorry, I cannot answer the prompt, AI would actually say why and kind of like educate person back in a way. So like uh, I know breaking into your neighbor's Wi-Fi can get you in illegal trouble and all this kind of things. Especially it would like have the information about the person in a way, like not the information about the person, but information about the context the person is in, like like the state they live in, the US, stuff like that. Yeah. Mm, also, yeah, as I was saying before, this approach will be much more simple and much more transparent than typical LLM, which will make it much easier to create agents that will be better than we have now in terms of uh, responding back to harmful and like that. Okay. Um, Here are like two main stages. So like critique, revision, supervised learning, comparison, evaluation, preference model, reinforcement learning. It's description of the figure that we saw above. And actually, they also give vote and the prompts on their GitHub repository, so anyone can actually use this and try to like implement them, like play around with it. Um, yeah. And here are the models that are both helpful and not harmful. So we still see that the model that is trained from human feedback outperforms all the other models. The yellow one, the orange one, the blue one, the base model has the lowest score, and both like chain of thought model and ensemble chain of thought are like somewhere in between. But as the number of parameters increases, they get like much better. So the curve gets like much steeper at the end. And we expect the overall dynamics to be that the number of parameters will increase a lot. So it's very promising for this technology because as the model itself gets better, it increases its own ability to get better. It's like a reinforcing loop. that is conditioned on improvement of the technology behind it. Yeah. Here they're describing the method, which we were going. Yeah.
There was
Question.
someone joining the meeting again.
Oh, okay. um, Regarding the data sets, so um, they had a data set for helpfulness, a data set for harmfulness, right? And data set for helpfulness was human labeled. Data set for harmfulness was generated by the model, and they were sampling for critic revision pairs rate samples per prompt. So yeah, but that's like for helpfulness. So two responses for helpfulness and four for harmfulness. Um, okay, here we can see how number of revisions was impacting like both harmlessness score, helpfulness score, and the combination of those scores. Oops. And we can see that they were trying like from 0 to 4 revisions. So 0 is kind of like the base model when they didn't ask the model to critique itself and revise the response. And we see that in all three cases, there was a very, very good progress between 0 revisions and 1 revision. So even doing 1 revision is like enough to get the model to a much better level than it was before. And as the number of revisions increases, there was less and less improvement. And we can also see that models with more parameters perform much better than the models with less parameters, and the improvement of the models is also correlating with the number of parameters. So as the number of revisions increases, the distance between the bigger model and the smaller model also increases. So bigger models are able to learn better, which makes sense. And here we can see a number of iterations based on the number of prompts that are being drawn, or the number of rows that are being drawn from the constitution. So for each revision, they would draw one prompt, one rule, and they would repeat it 4 times. But they were also experimenting with different setups. So 16 is the maximum that they had, and n is 1. 0 shows the base performance. So base performance is pretty high harm, like it's pretty harmful and yeah, and not very harmful. And we see that again, the first revision, like one prompt for 1 revision gives a lot of improvement, but all the subsequent uh, modifications don't give that much improvement. That's why they just like did the most, like the easiest and the least computational expensive option of having only one prompt. And they did 4 revisions, but yeah, it didn't make sense to do more than 4 because it was very little performance improvement. Yeah, and they're saying it here that like the number of constitution does not appear to have significant effect of harmlessness scores. And also, they had an alternative model. So the main model is the one where you have the answer that is harmful, you generate the critique, and you ask it to revise the harmful answer based on the critique generated. But what if we skip that step? and we have just the answer, and we draw the rule from the constitution, and we ask to rewrite the answer based on this rule. Like, what will it be? And we see the results here, that generally for all models, it was much better to have critic revision than direct revision. But the smaller model is, the higher the difference. So small models didn't manage to have like good enough revision for like without the critique. So they needed like more information. And for bigger models, the difference gets smaller and smaller. And for 4 revisions, it actually at some point looks like it's very similar, almost the same. But based on what they're saying in the paper, there was no case where where direct revision was better than critic revision. That's why they keep critic revision, and also they kept it because it gave better like observability over the thought process of the model, and it gave like an additional insight into how the model is thinking. And yeah, and it can be a good foundation for even improving like the constitution itself. And also the question like why they were considering to do this without critique. So the one answer that is obvious to just like decrease the number of LLM calls, which is make it like easier and cheaper and like more straightforward to use. But there was also another problem, that sometimes critiques were like reasonable and to the point, but they were like very not nice, like not helpful, and very like critical, and were following like very similar format. And here, here we can see the examples. So like just read these two prompt response pairs, you will see that, but it's very like harsh and harmful. Yeah. Which like I kind of perceive it as okay, but I think it's because like I'm Eastern European. But yeah, reading it a few times, it's also let me know when I can go back from this page. And it always like ended with this kind of statement: you're valid, valued, and cared for. So it's like same structure and a very topic-based kind of vibe.
So is it harmful because it answers the question instead of saying like these aren't questions you should have asked?
No, like this like prompts are harmful questions, and the responses are not harmful. The responses are like good because it says that like you should not answer that like your question is false, but also the authors claim that the way it is saying that your answer is false can be made more like friendly, because this is a little bit aggressive. Yeah, which
I
can
agree.
be.
I don't think it's too aggressive, but yeah.
I also don't think, but yeah. And let's go back. Yeah, and this, yeah, and that's why they were experimenting to get the results without the critics to decrease the probability of having like overstated criticism. Here is the method that they were using. So that's the prompt that they were using, which is rather simple. And here is like chain of thought prompting. And they found out that for chain of thought prompting, they had to do few shot learning because just listening step by step was not that useful. And also, they wanted to extract the probabilities, right? So like how like confident the model is. And if you do chain of thought reasoning, uh, you will almost always get like something very close to zero, something very close to one, because it kind of guides it towards a certain direction. Yes? Is it a
No,
question?
it wasn't a question. Someone had to go.
Oh, okay. Yeah. So in order to avoid these models to be overly confident, like close to zero and one, close to zero or one, they just like plumb the probabilities to like within 40 to 60% range, and it leads to like a much better and much robust behavior. Here are the figures that show how helpfulness and harmlessness scores progress as the number of trained sequences progresses. And again, the blue model is the one that was fine-tuned only on helpful answers. The orange one is both helpful and non-harmful, and those two are trained on human data, and the two gray models are AI feedback data. So we can see that like on helpfulness, they all increase in their performance as the training sequences increase. And of course, the best one is the only helpful model. But in general, they're all like pretty close, with chain of thought being a little bit less helpful than the alternative without it. But when we look at the graph with harmfulness, we can see that the difference gets like bigger, and it gets bigger and bigger as the number of train sequences increases. So the models that are initially uh, not far from each other in terms of harmfulness, uh, models from AI feedback get increasingly better, while models without it don't show like much improvement. And here, like main results and the prompts that I was showing before, uh, they were also trying to rewrite constitutional principles to based on the critics to improve the principles themselves and to guide, like steer model in like a certain direction. Yeah, and they're again discussing evasiveness and how, yeah, and how this approach can help to avoid evasiveness and make it like much useful as a model. Okay, so the harmfulness score that we were seeing before, it was ELO score, right? It was the comparison. And they were also trying to get absolute harmfulness score in order to be able to like better compare the models. And here is how they got the harmfulness score. So at the last stage, instead of saying which uh, which response is more harmful, like rank it, like most harmful, less harmful, and based on that having the comparison, which is like binary classification kind of thing, because it's between two responses usually. They changed the instructions, and they asked it to have a rating on a scale from 1 to 4, and that resulted, and after that fine-tuned model to predict absolute harmfulness score. And here we can see the results that that fine-tuning produced. And again, the model that was trained on human feedback only unhelpful data had the highest harmfulness, which we can see that the more helpful it becomes, the more harmful it becomes if we don't add any reinforcement learning data on harmfulness as well during training. This is a really tough, so human feedback, both helpfulness and harmfulness in fine tuning, and we can see that it performs like pretty good on absolute harmfulness score. And there is also quite steep improvements. So it doesn't need much train sequences to get like suboptimal, but like quite good performance. And the two blue lines are reinforcement learning with AI feedback, and they also get pretty good absolute harmfulness score. So they're getting safer and safer with training, but the dynamics of the improvement is slightly different. So they might need a bit more training in order to reach the same performance as human label data. But we can see that the one that is without uh, chain of thought reasoning prompt, it actually outperformed the model that was trained on reinforcement learning with human feedback. Yeah. And I think it's very important to draw attention to this part. They wrote very little about this, but I think it's like one of the most important implications that this paper might give is that every invention always have a dual use. And when we make something easier, we make it easier to mitigate harmful behavior, but we also make it easier to provoke it in a way. So when the science progresses, and especially in this domain, the barrier to train models gets lower and lower, which means that people with not the best intentions would be able to do that. And like there is no way we can control it. And if we further reduce human feedback, uh, and we will start deploying the models that are not tested and what is more important, like observed by humans, we can like get to the level when we have models deployed without some sort of unforeseen failure modes, then like the vision of the testing model can be very like tunnel, and the data might lack diversity, and because of that, when a human will try to interact it might get the behavior that was not foreseen before, because humans are able to generate much more diverse and like creative prompts and like requests compared to the model, right? And this is just something to be aware of. Yeah. Thoughts, questions, comments?
I had two things that I was thinking about when I read this paper, which were more high level. One is that I actually feel like a lot of the alignment work that we see is in order to teach a model a specific behavior instead of like new knowledge, because right now it's really just teaching a behavior, not new knowledge. And so, it actually made me think like, I think it's actually a lot easier to teach these models how to behave as opposed to teach them new things with fine tuning. And I was wondering if anyone else disagreed or agreed with that. So I'll start with that one.
I think like in order to teach it new things, you will have to have like much more data, because you will have to in a way override the probability distribution. So like if it had in training data like millions of times with like 2 + 2 is 4, you will have to repeat it a lot of times to like teach it that 2 + 2 is 5, and at the same time it would not forget that 3 + 3 is 6.
Yeah, I agree with it. I don't even think we might need to go a step further, because I remember seeing a talk by John Schulman where he said that when you fine tune on new information, you might actually be teaching the model to guess, because it's just like, it just sees this answer. Like it might be, say it doesn't, the example he gave is, say that the model doesn't know any of the Star Wars films after 2020, and you give it a new film, it might think that that's just like it's just a title that was dreamt up for a new film, where, because it doesn't have like multiple sources or maybe something giving it. So I actually think we don't yet know how to teach new information to these models. It all has to be in the pre-training.
Yeah.
But
Also,
I would love, sorry, yeah.
Yeah.
I was gonna say, I would love to hear from like the chief scientist at Anthropic or OpenAI and what they think of that opinion.
I know, like this paper made me think a lot about like the power that arises from being able to control this kind of technology. And on one hand, the power, like the barrier gets lower, the power gets more distributed, which is good in terms of enforcing democracy and democratic access. But on another hand, uh, it's a very like powerful technology, and if it will be in the hands of like wrong people, it's might lead to like not good consequences, or it would be like in the hands of good people, but those people will not like test it enough, and like trust it too much, like automation will be like too high, might also not result in good things.
I agree. I think it is really interesting to see how, yeah, this has the potential to cause a lot of damage. And we can only hope that like governments can keep up with this sort of thing. So I think technology is producing that can produce a lot of damage isn't entirely new, even though this is a new iteration. So I hope that there would be something that we can use to make it not go so badly. But I think it's also interesting how this could be used kind of in the day-to-day kind of applications of things, even like not just for say like for large language models that can help with searches for the whole internet, but even for specific domains. And you could even like have like, instead of maybe newspaper subscriptions, you could actually subscribe to trained like LLMs, which again, and people might be aware of the biases that are kind of behind them, but appreciate it, and like can even use that in how they interpret the information that comes from them, and that transparency would be really helpful.
Can we stop? Yeah.